All right, guys, I'm going to go over your exit ticket problems that you had trouble with throughout the unit here. You can use this to help when you're studying if you feel like it would be helpful. So here we go. So number one on, this is the 6-5 one. Number one, 40% of all classes got it right. 96% got number two right. So we look good on number two. Number one looked like this. So it was, let me get that over there again. Let's have to see. Square root of 3x plus 1 plus 10 equals 0. Square root of 3x plus 1 plus 10 equals 0. And I think what this was is this was a case of you guys not checking your extraneous solutions, which I didn't give you a lot of time, so that's fine. Anyways, we want to isolate the radical here. So minus 10 from both sides would give me square root of 3x plus 1 equals negative 10. Using a little number sense tells you at this point you really are not going to have a solution. You can't take the square root of a number and get a negative. And so you might know here it's no solution. But anyways, if we do the algebra, which I'll show, step from here would be to square both sides. So that would give me 3x plus 1 equals 100. Then we get 3x equals 99. And 1x equals 33. So that was an answer choice. So I think most of you solved it right and then just saw that answer choice and said that must be it. But just don't forget to double check those answers. So this is a good reminder to double check those answers. So if we went back to the original equation right there and type that in, square root of 3 times 33 plus 1. Plus 10, we're supposed to get 0, we get 20, okay? We get 20, not 0, so that's an extraneous solution. All right, so that's number one from the 6-6 exit ticket. All right, let's look at 6-2. I think we had one, or sorry, this would be 6-6 right here. All right, so number one looks kind of okay. 75% is not great, but it'll do for now. All right, number two, 25% got that one right. So we'll take a look at that one and probably be it. All right, so number two says perform g of f of x. I assume maybe we have to look back at number one to see the problem. G of f of x is also known as g of x divided by f of x. Let me see if I can find a rule for both. Let's see, I'm not seeing something. Let me make this screen a little bit bigger. Go back to preview. Maybe you got it wrong because there's no rule for g of x or f of x. Okay, there they are right there. Okay, so g of x is 2x plus 4. F of x is 2x minus 8. So 2x minus 8 and 2x plus 4. So 2x plus 4, 2x plus 4 over 2x minus 8. And I will say that I'm a little offended you missed this one because it's on your notes, but that's okay. Anyways, how do we reduce that? So you can factor a 2 out of both factors. So you could have 2 times x plus 2 over 2 times x minus 4. And 2 over 2 is equal to 1 over 1. So your simplified fraction would be x plus 2 divided by x minus 4. Might want to put those in parentheses. Don't have to, though. Okay. My domain restriction comes from here. I can't divide by 0. So what's my 0 of the denominator? It would be 4. So your domain restriction would be, it looked a little funny on the formative. Let me show you what it looked like. But so the domain, you're just trying to look for the one that says doesn't equal 4. So it'd be that one right there. So it says x and then has a line and then x can't be 4, which we use that notation in class. So just x can't be 4 on the test will work fine. Okay, so that's number 2 on the second formative. And then we really didn't have an FMQ, I don't think, on this one. But number 2, oh yeah, we did, number 4. So number 2, I guess I could show that just in case. I had to hand grade that one. I did not. Okay, so how do you, just in case you had trouble with this one, I'm assuming you're fine. It says, how do you know when a table of values gives, when a given table of values to give the inverse. How can you tell when tables are inverses? I think is what that's supposed to say. But you would know when X's and Y's are flip-flopped, something like that. Okay, I'm assuming you guys did fine on that. I just didn't grade it. Number 4, though, you did not do well on, so let's look at that. So it says select the transformations, domain, and range of. So there's some tough stuff in here, so let's look at it. So it's y equals -3 times square root of x minus 2 plus 1. I already forgot it. Let's try that again. -3 first. Bless you. All right, -3 square root of x minus 2 and plus 1 at the end. All right, so as far as listing the transformations go, I think you were selecting from a list here. It would be the first number, A, if it's negative, that's 2 transformations. So this would be reflect across your x-axis. I hope you guys who are talking are all in the video and everybody's like, God, his 6th period's so rude. I hope you're immortalized in this video forever. All of you. Love you guys. All right. And then the 3 part would be a stretch. Okay. So that would be a vertical stretch. Vertical stretch. I know it's a stretch and not a compression because 3 is bigger than 1. The absolute value of 3, or the absolute value of -3 is bigger than 1. So that's another thing. Under the radical, the -2. I think I'm going to run out of colors here. This -2. Let's see if I can do some writing above it. That'll work. That would be that's a left or right. Okay, kind of counterintuitive. This would be a right 2, right 2, and then finally the last one is a up 1. So you needed all of those choices, 4 things. I think if I look back, that's what I would see. Your domain restriction for this one is that square roots can't be negative. Okay. So you're just looking here for the domain right here. That's the only part that matters. So what x's make it negative under there, right? So you're basically thinking about x minus 2 equals 0. That'd be 2. So x has to be greater than or equal to that number. Okay, so x has to be greater than or equal to 2. That would be my domain. Okay, so anyways, that was a little clunky because it didn't all fit on the screen, but hopefully this helps. So a little something extra you can use for your studying if you like.